Now I'm going to look at a word problem which involves linear systems, and I'm going to solve it graphically as well. So if we look at this problem, write a linear system to model this situation. Wayne received and sent text messages on his cell phone in one weekend. He sent 10 more messages than he received. Now the two unknowns here are how many messages he received and how many he sent. So we'll start this with a let statement. So I'm going to let R equal the number of texts received, and I'm going to allow S, or I'm going to let S equal the number of texts that were sent. Now, if I look at this system, there's going to be two equations. So the first equation, I'm going to look at this. Wayne received and sent 60 text messages in one weekend. So the number of texts received and the number of texts sent should equal 60. That's the first equation. The second equation is coming from this sentence. He sent 10 more texts than he received. So if I start with the number sent is the number received plus 10 more. So it should look like this. So here's our two equations. Now we can graph this linear system and solve how many text messages he sent and received on this weekend. Now, it typically doesn't really matter which axis you put whichever variable on. So for instance, I could have the number of texts sent here, or I could put it here. It doesn't really matter as long as the numbers that you go up by on each axis should be the same. Now, since this second equation is already rearranged for S, and again, when I go to graph these, I want them in slope-intercept form. So I'm going to use S to represent my Y because this second equation is already rearranged. So if I'm writing on this graph, I would put this as my texts that are sent, and this as my texts that are received. So when I go to this equation, if I look, the numbers need to go up to at least 60. This is a maximum here, and this one, it looks like the y-intercept is 10 here. So if based on the space I have, I'm going to make every space worth 5. So I'm not going to write 5, 10. I'm not going to write every 5. I'm just going to skip a space and write every 10. So I'm going to go 10, 20, 30, 40, 50, 60, and then 70. Now, since I went by that on this axis, I'm going to do the exact same on this one. I'm going to have the numbers on each axis match. So every 2 spaces will be 10, and I'm only going to write the 10s down. Now that both of these axes match and I have labeled which are the sent and which are the messages received, now I'm going to graph. So I'm going to start with the second equation since it's already rearranged. You don't have to start with the second, I just will because I have this equation rearranged. So if I look, the y-intercept is 10. So that's my starting point. And then the slope is 1, or 1. I mean, it's 1r plus 10. So the slope is 1, which is 1 over 1. So every space that I go up, I have to go over 1. And you can do this even though realistically we're going up by 5s, because for every 5 spaces we go up, we go over 5 spaces. So that really maintains that slope of 1 over 1. As long as the axes are the same, like the numbers going up and the numbers going horizontally are the same, you can do this with the slope, okay? It is all right to do that. So again, now that I have a number of these points plotted, I can draw a line through these points. And then I'll go to graph the second one. So the first equation, if I rearrange this, It is r plus s equals 60. So when I go to rearrange this, I've already identified from this second equation that s is my y. So I need to rearrange this equation now to be s equals. I can't go and rearrange it to be r equals because I already made my text sent my y. So since s is my y, this is what I'm going to isolate. So if you subtract r on both sides of the equation, you would get s equals negative r plus 60. Now if you look at this, the y-intercept for this is 60. So I would find 60 along this cent axis and put a point there. The slope is negative r plus, it's negative 1. So the slope really is negative 1 over 1. So now I'm going to go down 1 over 1, down 1 over 1, and continue this pattern. Again, it is okay to do this as long as both axes go up by the same amount. If they went by different amounts, the slope, you couldn't use it the same way that I'm using it here, where I'm going down 1 over 1. Now, if we look, there is an intersection point. It's very clear to identify this. The intersection point here is this point, which is 25 texts received. So it's 25. And along the y, it's 35. So the solution to this system is 25 texts received and 35 texts sent. Now there is a way that you can verify this solution if you're not sure. So the verification goes back to what you would have learned last week. It isn't mandatory for you to verify, but if you're uncertain of your solution, this is what you can do. So remember, when you verify, you check your solution in both equations. All right, so we just verify with the equation that this solution works for both equations and that the left side is going to equal the right side. So if I substitute 25 in for r and 35 in for s, 25 plus 35 is 60. So this solution works for this first equation. And then you would go ahead and also check it for the second equation. The second equation is this, s equals r plus 10. So if we're checking, text sent was 35 and r is 25, the received is 25. So if I check, my left side is simplified to one number, and my right side, if I add these together, is 35. So this works in both solutions. So this solution works in both equations. So this is the correct solution for this system. 25 received and 35 sent. All right. Again, the verification isn't absolutely mandatory, but it is a way to check your work to see if your solution is correct.